Data versioning. When you start working on a file, be it a text file, a script file, or even data that you recorded, every time you either make new or change and save your progress, then you create a new version. In many cases, you don't create separate versions, but just save over it. But sometimes it's very useful to have a chronology or have the changes be available to you. So you can look back at your file and see what you changed at a certain point in time. One very basic principle of versioning is a file level versioning. You have a version control, say, by naming your files accordingly. That already enables traceability of the changes. If you make major changes in your script, for instance, which you use for analysis, then you can later see where I added feature A and B. One other thing about file level versioning is it works for every file type. You can use it for every file just by changing the name of the according file. Some naming conventions, which might be very obvious to some, but you would be surprised how often that does not work in many fields of science, especially if we're working with a team on the same file type or on the same file basis. It's very important that everybody in the team is on the same page in terms of how you name files and what you include in the name. File names should be descriptive and clear, that everybody is able to discern the content or the purpose of that file. It's also very useful to include some metadata information, for instance, a project name, if you have sub-projects within the team, a date, researcher initials, or a name. You can also include some version numbers, but also just general description of the data can be useful, but it shouldn't be too long. One more important thing is each version name should be unique, so you don't overwrite your files. It's very important. You shouldn't use special characters. For instance, space is a special character. It does work on many operating systems nowadays, so please, if you want to separate words or the description of the files or the parts, then use underscores or hyphens, which are much better in terms from a technical perspective. Software usually have their versions in three parts: a major, minor, and a patch version, which are separated by dots. That's true for most of the software out there. With that, I want to come to Git. The idea is that you take a folder on your file explorer and promote it to a Git repository. The Git repository is, as the name suggests, is just your folder, but it contains a hidden version database. For future reference, the contents of your folder will be called your workspace. Git is a program, and it checks your folder and it sees all the files. Git is originated in software development, and software developers usually have text files. So Git itself also thinks all files within your folder are text files. Because one of the very powerful features Git has, it can compare files and show you the differences in your files. If you made a change, then Git can tell you you've changed in that line these characters. But that's only useful if you have text files. Microsoft Office, for instance, or Word is not a basic text editor, and doc files or docx files are not text files. They are binary files, they're compressed files. For those files, Git itself cannot show you differences. There are differences, but it cannot display you properly what differences you made. You have to keep that in mind when you work with Git. What Git does is it creates a version history, or you can create versions of your folder, which you then save within that version database, which is created when you create your Git repository. Each version is made of a set of changes. You can include changes and then commit them and create a version. How do we commit or save a version of our files? Git itself tracks all the files within our folder, and then we can tell Git to include all changes we want to be in a new version. When we want to create a new version of our folder, then we tell Git by git add to add them to a staging area, and all changes within the staging area will be together will be the changes which are included in the version. The sum of all the changes we want to add together to a new version, we'll commit them to our repository. That's the terminology which is in Git, and create a new version. We have a new commit and a new version. The content of our commit is not only the changes that we made to the files. So if we made some typo corrections or we made additions to scripts, but there's also some additional information included in our commit. It has a unique identifier, which is important later on. One important thing is you should always add a message describing the purpose of your commit. Usually, you would add changes which are logically connected to each other. That's not required from Git. Git doesn't care. But from a logical perspective, it makes sense to add logically connected changes within a commit. When you later look at the different stages of your files, or you want to check why you changed something, or someone else wants to get the idea why you came to this place or why you made some changes, then it's always good to have a message describing what you did. It includes the name and email address, which is important to discern who made the changes, and also aid in the time. In the lower part of the screen, I showed you the metadata, which is included within a commit. You can also have just a remote repository, so it's saved somewhere else, for instance, the internet, a GitLab instance, or GitHub, or whatever. Then you have your computer, where you have your local repository and your workspace. So the folder which you're working on, if you're using that, that's the workspace, that's the actual contents of your folder. You have two more stages in Git. You have the index and the staging area and your local repository. You start with initializing your repository by either doing it locally and creating your own repository with the init command, or you can clone it from a remote point. If you make changes and want to create a new version, then you add all the changes you want to be in your new version to the staging area, and then commit them to your local repository. All the changes are available as a new version. This graphic in principle is a lot longer because there are a lot more steps or things you can do with your repository. You can look at the log, which shows you all the messages or all the information which are included within a commit. And then you can also show you the differences from version to version. That's a very powerful tool, especially if you're working with many people or as a team on a project. All your commits are then chained together. The history of your folder is always connected. So each commit you make references the previous one, and you can always reconstruct your state. So you can move your workspace either by checking out the actual commit you want to go back to, but you can also cherry pick. For instance, if there are many more commits in between and you only want to reverse certain things, then you would cherry pick individual changes and transfer them to your current directory or your current folder. The next thing I want to mention are branches. Our commit history are all linked together, and I showed them as a straight line, but it's also possible to branch off and create two parallel tracks of your folder, two different states of the same workspace, the same folder. That's especially useful if you want to try different parameters, if you're using your Git repository for your evaluation scripts. But it's also very useful if you're working together on the same files as a team, so that you ensure that you don't interfere with the changes of someone else. It can be very useful to create branches. And that ensures that you don't overwrite changes from someone else. Everyone who creates his own or her own branch has her own state and does not get interference from other people who are working on the same thing. Branches in general are not meant to stay alive forever. It is useful to merge them back into the main branch. In theory, you can also let branches live forever, but Git itself is made so that branches are not meant to stay forever. They are only meant to be alive while you develop a feature or work on a certain thing. and then merge it back into the track. When you merge your branch back into the main track, sometimes you have conflicts because someone else changed the same files, and then you have to decide which is the correct file. It shows you the changes for text files directly. So you can see I made change A and someone else made a different change of a certain line. Then I have to decide when I'm merging my branch which is the correct one. That sometimes involves talking with your team and then decide together what the correct state should be. Git likes to work with text files, but you can also work with binary files, especially if you're working with large files. For instance, your research data, which not always is in text form, but you still want to use version control for them, then Git offers the LFS, the large file storage, which is more or less a different program, which is an integration to Git, where you can also store or version control large files or bigger chunks of data. It works a little different from Git. Your new versions are blocks of data, and every time you make a new version, you create a new block of data. So you have to keep that in mind. If you are making multiple copies, you always require more space because Git can save just the difference in your files. Just some very brief introduction to GitLFS and how it works. You can install it like Git, and there are a lot of documentation available on the internet. Then you have always to set a username and an email, which is important for when you're committing changes to your repository. Then in general, you tell GitLFS to track certain file types. If you have your big data, which is not a text file, is always the same file type, you can tell GitLFS, use GitLFS for file types like PNG or JPEG or whatever your file ending would be. Or you can also tell it to track certain folders. Then Git knows for this folder, I need to use GitLFS. And then you can list all your files which are included, and it works in that sense the same as Git. In Teams, it's useful if you're working with big data and want to version control it, that everyone is using it, and it should be set up in the same way, that you don't get problems when someone is not using GitLFS and pushes their research data into your regular repository. It can overwhelm some systems or some repositories, especially if you have restrictions on how much storage you are able to use. And you can also lock your files if you don't want somebody else to change your files. You can also exclude certain files from someone else if you don't want to download files from researcher, from your colleague, because you don't use it or you don't need it. When you synchronize your repositories, or especially if you're working with a local version of Git, then you can tell it not to download certain things, because big files are sometimes impractical to download. That's just some brief basics about Git. There's a lot more information available online. How can we make Git a little bit easier? In this day and age, we usually have graphical user interfaces, and Git works with that as well. One very common way to use Git is use it as an integration for editors. For instance, here I showed the Git integration for VS Code or VS Codium. There you can have all the features of Git and use them within your tool, which you use for editing your files anyway. So that makes it already a lot more accessible and easier to use. And you don't have to worry about all the individual Git commands, which you would otherwise have to enter in your terminal or your PowerShell. The one I want to actually end up to is a GitLab, or is working with remote repositories, have a central storage, which is especially useful if you're working collaboratively on something and as a team. Then it's always a good idea if you have a central storage, which everybody can access. GitLab, for instance, is such a platform which offers you a central storage for your data, and it has a distributed version control for everyone. As I mentioned, we're back at that graphic, and we also have now an orange path, which is the update path. We have a little bit more if we want to synchronize from our local repository to our remote repository there. are some new commands which are available. That's fetch and merge or pull, which synchronize commits from our remote to our local machine, and push as a new word, which pushes our changes or the changes we made in our local repository to the remote. With that, we are at our GitLab part. GitLab is a web application for managing your Git repository. So you get a graphical representation of all your files, your commits, your branches, and all the commands and all the activities you can do with your repository. GitLab offers many things which are beyond the scope of just Git. You see my lab itself, but that's a bit more useful to show you actually how it looks like in the real world and not just slides on a presentation. GitLab is a graphical representation of all your files, or the web platform where you can access all your files. And then you can see all the things we talked about initially. So you can see all the changes you made to the repository, the history, and then you get a list and see all the changes you made to your repository. You can also view your branches, for instance. You can have many branches of your repository, as I said. This test repository has one. You can have multiple branches, especially if many people are working on the repository. You have the commits I showed you, and the files itself you see here. Below there, you see the README. If your repository contains a README file, which is called README, then it displays the contents of your file, but otherwise, you just can click on your file and see the content of that specific file. You can also have merge requests. If you create new branches and you want to merge them back into the repository, you would see them here. You can resolve them on your own. Then they will just show up in your history as a merge from a certain branch back to the main branch. You can also edit them. You have two ways to edit them directly within the platform. You can either edit your single file. So you open your file and edit the text of your single file and then commit changes. The other way is the Web IDE. The Web IDE is a powerful tool, which is very handy if you're working with your repository. It's based on Visual Studio Code. There you get all your files and can directly edit them, but you can also create new files, for instance, and new folders and move files around. That is what I want everybody to do. Create a new branch or edit some files and then merge them back in and try out different things. GitHub and GitLab, those are basically two platforms which offer you access to repositories. They offer you version control for your files. Both do that, but apart from that, there are differences in the sense that GitLab offers you different functionalities which you cannot access at GitHub, and vice versa. I'm not sure whether there's a publicly available instance of GitLab, but a lot of universities or institutions offer or host a GitLab instance. This is the GitLab instance of our university, and all the major universities usually offer GitLab or access to GitLab. I will briefly show you how you would create a new file or you would create a new branch. There's always the plus button, which lets you create new files, upload files, create new directories and new branches. For instance, if you want to create a new branch, then the branch name should be something descriptive so you know what you're doing. And if you want to, for instance, create a new feature, add my initials, and then create a new branch from our main branch. Then I have a new branch. Someone else already created some branch as well. You can use the Web IDE, which is especially useful because you can edit multiple files. Then you can add some new text. What happens then is you made changes to that specific file, and it also shows you what changes you made. We can move some files around and move them via drag and drop. Then it asks you, did you want to move your file? Yes, I want to move them in that folder. You can add new files. create a new file, new data, for instance, and add data to it. Then it shows me all the changes I made. Then if you want to commit your feature, add the message. Then you would commit your changes and add them to your feature. If we then look at how our history looks in our feature branch, we see all the changes we made. Then you can create a merge request. It asks me what branch I want to merge back into which branch. And then I can add some additional titles as well. Add a description if it's a little bit more contained. Then I can assign reviewers or assignees, milestones, because GitLab offers you a lot of features for project management as well. I see all the changes which are included in the merge request. I can create the merge request if I don't have any conflicts. If we did not edit the same file, then I get a green button and it tells me everything is fine. Then I can merge. Then my branch vanishes all the changes I made now within the main repository. This web application, and that's not always practical, because if, for instance, you're on a train or wherever, or where you don't have access to the internet, you can also link your GitLab repository to your local computer, your remote. So then you clone the content of that repository to your local or to your PC. And to do that, the good practice is to have a way of authentication. And the good way to do that is use SSH keys. There are a ton of documentation on how you create your SSH key, but that would be a good way to do that and to work with your files on your local machine. So you get a copy and then can use the git commands to push your changes from your local files. You use an editor which has a git integration and let the integration do the work for you and synchronize your remote repository. So for instance, the things which you use on GitLab, for instance, and the information or your file content you have on your local machine. GitLab has many more features. The main things I want to highlight is GitLab Pages. GitLab offers you the possibility to create websites. So even if you're not used to a web development, you can use Git to host web pages without having to worry about getting an external hoster for your website. You can just use GitLab. And there is the CI/CD, which is a way to create automatic tasks for your repository, which can, for instance, do an automatic conversion of files. But that's also a bit more of an advanced feature. It's in general a good idea if you're working together on a project and want to have a history of all the changes you make and have all the changes traceable, to use a platform like GitLab to have a central storage and a collaborative workspace, which you can use to work together on something. Should any PhD student researcher be using Git? From my perspective, advanced in the sense that if you're not used to it yet, it takes a little bit of time to get into the Git workflow and get a feel of how you use it and how it works for you. But no, I think even students can use it for projects or for lab tasks, which you have to do. It's useful to have a central storage. If you get used to the UI, working with it becomes relatively easy. After some time working with it, then it's just using your local text editor. And you can add your files, your scripts, and everything. It's not just something which are useful to advanced users, but actually useful to a lot of students and PhD students and students in general and researchers, obviously, and not something very specific, which is only useful to software developers. All the changes one makes to some scripts, for instance, are good changes, and sometimes you break stuff. And if you have a version control of your files, then you can always go back and see, I changed this and that. But depending on how many projects you have in parallel, it's not always easy to keep track of each project. And sometimes you inadvertently change something. I think it's useful for everybody. GitLab usually likes to stay within one platform. The focus is that people who are signed into that particular instance, be it the GitLab.com one or a hosted one like the University of Marburg one or your institution one, then it usually works best if all the members are logged into that specific platform. Then you shouldn't have any troubles inviting members who are logged into, or invite people who are members of that specific instance of GitLab.